Hi, good day everyone. Today we're going to present on Titan submersible implosion incident, video 2. This is related to ENGG 687, Ethics, Law and Engineering Profession, Team 87. I'm Keyur Patel, currently studying Masters in Mechanical Engineering. The rest of the people will introduce themselves as they present their part.
Hello everyone, my name is Harsh Vishwakarma. I am from Masters of Mechanical Engineering. Today I explain Titan Submersible Implosion for subject Ethic Law and the Engineering Profession. In the beginning part, I explain the case summary. On June 18, 2023, the Titan Submersible imploded during a dive to the Titanic wreck site, killing 5 people. The submersible was operated by OceanGate Expeditions. OceanGate Inc. is a private company based in America. They provide this service such as research, development, tourism, and general exploration. This submarine was capable of diving to great depth designed for exploration. They have been providing this experience for many years. However, currently suspended all explorations as indicated by their website, which the screenshot it is provided on the right side of this slide.
In this slide, we see how bias lead to poor engineering choices and a tragic result in the Titan submersible disaster. The first one is overconfidence. Stockton Rush was very confident in his own method, even though he didn't have much experience in submersible design. He ignored safety concerns and fired employees who raised them, and also seeing safety rules as an obstacle for innovation. The second one is a confirmation bias. The Ocean Gates teams mainly look at information that supported their belief that a carbon fiber was safe to use, even though tests showed it could be unsafe. The third one is a regulatory avoidance. Ocean Gates operated under the Bahamas flag to avoid a stricter regulation and escaped inspections from class societies that usually check submersible. Rush viewed regulation as a barrier, which led to inadequate safety check for this risky project. The last one is financial pressure. Rush had invested a lot personally in Titan, so he felt pressure to keep the expedition going to cover cost. This creates a bias toward taking risk instead of focusing on safety.
Hi, next we will be seeing about the system issues that causes incident. We can say that there are no regulatory oversight that was practiced during the construction of this submersible, and there was no agency that could certify that this submersible is ready or fit to go to the extreme pressures in deep ocean. And the second reason is the inadequate safety protocols, and the reports that came after the incident proved that there were insufficient emergency protocols and trainings and safety trainings for the crew that was inside the submersible, which resulted in this catastrophic incident that resulted in the death of all the crew members. And if you look at the third reason and a major issue why this happened is the design flaws. And this Ocean Gate submersible actually used some unconventional materials like carbon fiber to create the hull of the uh, vehicle, which resulted in reduced structural integrity of the submersible, and which ultimately led to it giving away for the massive pressures in deep ocean, and which resulted in the death of all the crew members. And these are some of the system issues that caused the fatal accident, and these must be avoided at all cost.
In terms of the lesson learned, we must prioritize safety over expedition goals. Another important lesson is ensure robust regulatory framework so that there are no loopholes for defect in the first design. Conduct thorough risk assessment and also encourage open communication and whistleblowing. The graph on the right just shows combination of a risk versus impact. So this is a risk assessment where what is the probability of a condition to occur versus what is the cost, as the item represented in red, which is the most critical item that needs to be addressed. So those are the items with highest probability and highest impact. So that will result in highest effect. For future prevention measures, we must establish strict submersible design and operating standards. So therefore, create a regulatory code for such operations. There must be regular audits and inspections. There must also be mandatory crew training and simulation exercise. For example, the one on the right is a simulator for a maritime simulator where one would be operating as if they were in the design module, and what are the different tasks that the person must carry out. And then in terms of the risk assessment, the independent safety monitoring and oversight must be increased. So there is a third party must be involved when doing safety inspections, and also encourage industry collaboration and information sharing. So for areas where, especially when you are pioneering into a field where there is very little knowledge or experience available, it is sometimes better to actually collaborate and share whatever the information that becomes available to all the parties involved or interested. The slide just represents some of the sources that were used to prepare our presentation.